Now we go to the example 4.8. Actually, this one is similar to that of the example A, but now the integer is 2 instead of 1. So the same technique we need to apply is that we need to expand this 2 into a fraction. So the first fraction, we no need to have any changes, but it's better for you to add a bracket for the denominator. And for 2, we use the same technique as the part A. We times a fraction with the 2x plus 5y as both the denominator and the numerator. After that, we can see that now for these two fractions, the denominator will be the same. Right? So now we can subtract the later one from the one in front of that. We can change it into one fraction now. That is 6x minus 2 times 2x plus 5y. And the importance of using the bracket here is that you can see that, okay, actually we need to expand this expression. And when we expand this expression, for the later part, that is negative 2 times the positive 5y, if we miss the bracket, we'll have a very high chance to get a mistake in the negative sign. Okay, so please remember to add a bracket here. So now we expand it. So that is 6x, and then minus 2 times 2x is 4x, and negative 2 times positive 5y, that should be negative 10y for the numerator. You see? So lastly, the answer should be 2x minus 10y divided by 2x plus 5y. Is that the answer? We need to think about that. Can we have a further simplification of the numerator or denominator? So how we should check it is that we need to check, is there any factorizations that we can do? Actually, yes. If for the numerator, it will becomes 2 times x minus 5y. But after the factorization, is any terms can be divisible, is divisible from the numerator or the denominator? No. So this one should be the answer.